says, well, it doesn't really say anything. It just has this expression, and we're supposed to simplify it, I assume. So really, this just comes down to knowing your exponent properties. I might actually write that up, make a little note up here, is if you're not really familiar with these exponent properties, what I'm about to say and kind of my explanation here might be a little confusing. I'll try to break down each property as I go through it, but if you're not really familiar with these, you definitely want to go back and review your exponent properties. Okay, there's quite a few of them, and so it might be worth just going back and looking at those. And I would just, go to YouTube and type exponent properties explanation or anything like that, and you should come up with a pretty good video that sort of goes over each of the exponent. But let me show you how we would do this one. We've got x to the negative fifth times y all over y cubed. Okay, now I'm going to simplify this probably a little differently than you may have seen before, but hopefully it'll all make sense. So the first thing I'm going to do is try to rewrite this so I don't have a fraction. Okay, now the exponent property that I'm going to use here, and I'll just kind of keep track of them over here. First one I'm going to say is that anytime you've got a negative exponent, so let's say I've got x to the negative a exponent, so like negative 2 or something like that. I can rewrite that as 1 over x to the positive a. And so that's how you deal with these negative exponents. But what I'm actually going to do here, a little unconventional, is I'm actually going to use this property backwards and try to rewrite this so there are no fractions involved, at least not up front. Okay, so this y cubed is really like 1 over y cubed, okay? Y cubed's in the denominator. And so if I use this exponent property, that means I can rewrite this as y to the negative third. Okay? And so what I'm going to do is just rewrite this, and instead of having this divided by y cubed, I'm going to multiply by y to the cubed. I'm sorry, not cubed, to the negative 3. Now, another thing that I might want to point out here, this is another exponent property, is that anytime you have just a regular old variable here, that's the same thing as saying that variable to the first power. Okay, so if you don't see an exponent written, sort of an assumed 1 there. The next thing I'm going to do is try to combine these y's. Okay, so the way that you combine y's when you're multiplying is called the product property. And again, I know I'm running through these properties pretty quickly, which is why at the beginning I said go look these up so that you can be a little bit more familiar with them. But basically, if you are multiplying 2 powers and they have the same base here, the way to combine them is you add the powers up. Okay, and so if I have y to the first times y to the negative third, I can add those up, and I get 1 plus negative 3, which is negative 2. Okay. Now we've got another property. Okay, and so yeah, this problem really requires that you know quite a bit about exponents here. And that is, I'm raising this whole expression to the negative first power. Now, I know we talked about negative exponents, but I don't really want to deal with that negative exponent yet, because first, I'm going to say that if I've got any product, so like say x times y, and I raise that to a power, that's going to be equivalent to raising each individual factor by that power and then multiplying those separately. Okay, it's almost, it's not the distributive property by definition, but it kind of works like the distributive property, like visually, right? So, it's technically not an application of the distributive property, but it is very similar. Now, if I want to raise each of these to the negative first power, which is what I want to do here, I basically want to kind of like distribute this negative 1 to both of these. I actually need to know another property, and I know this is getting kind of ridiculous with the number of properties I'm listing here, but that's just the way it is. Okay, I'd rather give you more information than not enough. Okay, so the next property we are going to use, and I think this may be the last one we really need to call out here, is whenever you raise a power to a power. So let's say we have something like, x to the a. Really don't want to put a number on here because I want to write it generally. And let's say I raise that to another power. The way you can combine these is through multiplication. Okay, so you just multiply the powers together, a times b. That way you get rid of this power to a power. And this is called the power of a power property. Power to a power property, something like that. But anyway, at any rate, we're going to basically distribute this -1. We're going to raise each one of these factors to the negative first power. And since they already have a power on them or an exponent, we're going to multiply those exponents together. So -5 times -1 is going to be +5. And -1 times -2 is going to be +2. And there we go. We got our answer here. So our answer is choice C. And that's about it for number 15. I would recommend going back and reviewing these exponent properties because you do have to be pretty familiar with them to get this one right. Now, if you're worried about not being able to remember all these exponent properties and a problem like this kind of makes you a little uneasy, well, one thing you could do as sort of a fallback strategy is just to pick a value for x and y. And they could just be any numbers, maybe not make them the same numbers, but say like x equals 1 and y equals 2. And then just type this into the calculator, except with those numbers that you picked. And it'll equal something, probably some fraction or something. And then use those same x and y values to plug in here and all the answer choices and see which one gives you the same number as the original problem. So you can kind of, I hate to use the word cheat, but you can kind of cheat your way through this problem without knowing any of the exponent properties. Just realize that you can plug your choice of a number into x and y, compute this out, and do the same thing with the answer choices. I had a similar problem like this. I want to say it was like number 13 maybe, or no, maybe it was before that. Yeah, with number 12, if you watch this video, that was a strategy that we could use on this one too, where we just pick a number for x, plug it in, and see which one's the same. And really, you could use this strategy for any of these problems where you're just trying to identify which expressions are equivalent. So anyway, here's the sort of proper way to do it, but also consider that other fallback strategy that we talked about too. That's it for number 15. Y'all have a great day.